Hello students, welcome back in a lecture series of fluid mechanics. We are learning unit number 2, fluid statics. Today is lecture number 5 of this topic. Myself, Praveen Yadav, assistant professor in mechanical engineering. So in last lecture we have discussed about buoyancy force and buoyancy concept, as well as we have discussed about the flotation. So what is buoyancy? Buoyancy is nothing but the opposite force applied over the body which is going to be immersed in a fluid. If the buoyancy force is more than the weight of body, then the body is floating over the fluid. If it is less than, then it will be submerged inside that fluid. So that is the effect of buoyancy. Now in today's lecture we are going to discuss about the stability of floating and submerged bodies, metacentric height, and its application in shipping. Okay. So after aid of learning objective of this subject is to know equilibrium state for floating and submerged bodies and to understand about the metacenter and metacentric height. At the end of this lecture, you will be able to explain the concept of equilibrium state for floating and submerged bodies, as well as you will be able to explain about metacenter and metacentric height. So, what is buoyancy and center of buoyancy? In last lecture only we have discussed about buoyancy. Buoyancy is nothing but the opposition provided by the fluid for the body which is immersed, which is kept over the fluid. If it is weight of body is much more than the buoyancy force, then body will submerge inside that fluid. And if it is less than that, then body will float over that surface. So the force that tends to lift the body is called buoyancy force. Now here we have given the example of hot balloon. If it is positively buoyant, that is, if the hot air is provided to the balloon is about more than 100 degrees Celsius, then balloon will try to lift in upward direction. So here lift is greater than weight. If it is up to 95 degrees Celsius, we have kept the air temperature inside the balloon, then it will be in equilibrium position. That is, it will not go beyond above as well as it will not go down. It will be stationary at there. So it is called as a lift equal to the weight. And if further decrease in temperature, will tries to move the balloon in downward direction, which is called as a negative buoyant, and balloon will start to lift downward direction. So here lift has force is less than weight, and due to which it starts to move in a downward direction. So with respect to this, it is an upward thrust exerted by liquid or body floating or immersed in it, and it is equals to the weight of the liquid displaced by the body. The point through which the force of buoyancy is supposed to act is known as center of buoyancy. Now what is center of buoyancy? It is the particular point through which the force of buoyancy is supposed to be act is known as center of buoyancy. Okay. Again, this is the buoyant force and flotation. So here buoyant force moves in upward direction, weight moves in downward direction. If buoyant force is equal to weight, the objective floats and it is stationary. If buoyant force is more than its weight, then objective will move in upward direction. And if buoyant force is less than weight, then objective will move in a downward direction. That is, if this body is required to be float stationary, buoyancy force should be equals to weight. Further increase in buoyancy force, this body will move in upward direction because buoyant force in upward direction. Further increase in the weight, this body will move in a downward direction. So this body will move in a downward direction. So this is the effect of buoyancy force, and depending on that only flotation is dependent. So these are some examples of buoyancy problem. Buoyant ships are continuously obviously designed to float, because both of requires to can float. The diving bell would tend to sink unless supported by the cable from the crane on the ship. It is provided for the identifying the protection or some obstacles in between the path of your ship. Then consider any kind of boat, raft or other floating objects that is expected to maintain a particular orientation when placed in a liquid. Submarines are there, some anchor blocks are there. They should be placed in such a way that they can give the highlights to the shipping ports. So here in a water, everyone has its own role. In a ship has to be float, diving bell should be submerged, buoy should be half submerged, half should be open. Then submarine should float over the body and like that. So that is the examples of buoyancy. Now, it is essential to discuss about the equilibrium condition of the body. Why it is essential? Because in the last we have seen some example of ship. Ship has to withstand against all kind of forces in a water, but in sea there is a continuous wave formation in the sea, or some movement of water which may change the force of buoyancy and which may result in an accident, because sometimes buoyancy may increase, sometimes may decrease. So increase will lift the ship in upward direction and decrease may move the ship in a downward direction. In that case, there is the chance of accident. And to avoid that, we must know in detail about its equilibrium positions. So basically, first we will discuss about types of equilibrium. In equilibrium condition, body either stable, either neutral, or either unstable. What is stable condition? In stable condition, the body returns to its original position if gives a small angular displacement. For example, in this shape, from here, if I give from this position, if I give the angular displacement up to here, body will oscillate over this surface, but finally it will come to the equilibrium position. That is at rest position. Indifferent or neutral position, it is the flat surface. Over the flat surface, ball is rolling. If you give the initial displacement, it will move to the next position and keeps as a constant. So it is called as an indifferent or neutral. And unstable equilibrium is nothing but if your body is oscillates from here at the top of this, then with the small movement also it will give the maximum displacement. With the small displacement also it gives the maximum displacement, and that is called as an unstable condition. So stability of immersed and floating bodies is required to be considered, and it is the most important phenomenon. The important application of buoyancy concept is to assessment of the stability of immersed and floating bodies when no external attachment, and it is highly essential for the design of ships and submarines. So here again some examples of stable and unstable conditions has been explained. For this purpose, we will take one example of balloon. So equilibrium of submerged bodies discussion purpose, we will take the examples of balloon. Let's take the example of balloon which is completely submerged in air. It is kept in air. Now, suppose air is filled inside the balloon and balloons take vertically in upward direction. Then FB will move in an upward direction, GW will move in a downward direction. If I incline balloon with some sort of angle, I incline the balloon with some sort of angle, then it will move in that direction. FB will move in a vertically upward, GW gravitational force will move vertically downward, and it will rise to an again straighten. Again, it will be traced to an straighten. And you generally observe, if you have kept a balloon in your hand and if you swell it, then it will be traced when it comes to its original position. But opposite to that, if balloon is kept in opposite direction, that is its opening will be moved in upward direction and closing its circular surface is in a downward direction, and if you give some angular displacement, then there will be the unstable condition. And in neutral condition, B and G should be at the same position and it will be of stationary condition. So if G is below B for totally immersed body, then G and B is fixed. Stability of submerged body can be determined by location of G and B only. When the balloon is completely submerged in air, W is the weight of balloon and Fb is the buoyancy force. Then for equilibrium condition, Fb must be equals to W. If G is above B, if the balloon is given a small angular displacement theta in clockwise direction, then W and Fb produces couple acting in same direction of displacement, so the body does not return to its original position and body is said to be in an equilibrium position. It starts to oscillate. And if G and B are both of same point, and if the balloon is given a small angular displacement in any direction, there is no any couple producement. Where W and Fb is acting in the same point of body, it is called as a neutral equilibrium. For example, your balloon is a completely circular position, and if you are giving the angular displacement in any one direction, it will roll like a ball. It will roll like a ball, and it will be kept constant at newly provided position. So from this, we are going to introduce one more concept, that is metacentre, which is called as a metacentre. What is metacentre? When a body is floating in a liquid, and is given a small angular displacement, it starts to oscillate about its point, and that point is called as a metacentre. That point of oscillation is called as a metacentre. For this body purpose, B is the position from where weight is acting in a downward direction, G is the center of gravity, and M is the metacentre point. Then when body starts to oscillate, it oscillates with respect to the point M. It will oscillate with respect to the point M. Metacentric height is the distance between the center of gravity of the floating body and the metacentre. So suppose if it is the G is the center of gravity for this body, buoyancy force is acting at the point B in upward direction, W is acting in downward direction. Then metacentre is the point from where body is oscillating. With respect to that point, body is oscillating. Then the distance between the metacentric point M to the G is called as the metacentric height. Now, stability of floating body. A measure of stability of floating body is the metacentric height. So distance between the center of gravity G and metacentre M, the intersection point of the lines of the action of the buoyancy force through the body before and after rotation. The body is stable if point M is above point G, and thus Gm is positive, and unstable if the point M is below point G, and thus Gm is negative. That is, if metacentric height is positive, that is G is below the M point, then body is called as stable, and if it is above, then body is called as unstable. Now measurement of stability. Here Bm be the metacentric radius, then Gm be the metacentric height, and up from the bottom of body to the top, it is called as a Km, that is height of metacentre, total height of metacentre. The distance between center of gravity to the base is called as a height of gravity, and you know that height of gravity concept. Now equilibrium of floating bodies. The stability of floating body is determined by location of G and M, and there are also three types of equilibrium in the floating bodies, that is stable, unstable and neutral. That part we already discussed. Now stable equilibrium. When M is above G, then W is equals to F of B, that is weight is equals to buoyancy force. If the floating body is small angular displacement theta in clockwise direction, then the center of buoyancy shifted from B to B1. Center of buoyancy will shifted from B to B1, and the buoyancy force FB through B1 and W is produce a couple acting in anti-clockwise direction. Hence, floating body returns to its original position. So, floating body is said to be in stable equilibrium condition. Are you getting my point? Here, B point shifts to B1. B point shifts to B1. But G remains same, weight in a same position in a downward direction, because center of gravity will not be going to be a change. So this creates a couple. This creates in a couple, and due to that couple, body will tries to comes to its original position. In unstable equilibrium condition, M is below G. Metacentric point is below the point G, and if the in a small angular displacement theta is given in clockwise direction, then FB and W produce a couple acting in clockwise direction and hence overturning the floating body. So this will help to move the body in a downward direction, and it will tries to be a turn with respect to point G. The neutral equilibrium position M and G are said to be at same point. So if the floating body is given small angular displacement in any direction, there is no direction of couple produced due to W and FB, and body will move to the next point. Since W and FB are acting at the same point and floating said to be a neutral equilibrium. The floating body. A floating body possesses vertical stability, while an immersed and neutral buoyancy body is neutrally stable since it does not return to its original position after a disturbance. A floating body possesses vertical stability, while an immersed and neutral buoyancy body is neutrally stable since it does not return to its original position after disturbance. So suppose this is the body having weight, some weight and then fluid, then it will be stable in a bottom position because weight will be at the bottom. But if it is above that, then it will be an unstable condition. So immersed neutral body is stable if the center of gravity is in direction below the center of buoyancy force B of the body and is reverse, then it is called as an unstable. That is, if G is directly above B, then it is unstable. Now, what is stability? Stability refers to the ability of ship to right itself from a hilled position. A floating or submerged body is said to be stable if it is its position, if it returns to that position following a small disturbance, which is generated due to the some change in direction position, some changes taken place in the air, etc. due to that. Now this is the example of floating body. If metacentre is above the top of ship, then small movement, angular movement will not cause any kind of accident or overturning, and body will come to its original position. If metacentre is below, then it will develop an angular couple and which will result in a overturning, which may result in a overturning. So a floating body is stable if the body is bottom heavy and thus the center of gravity G below the centroid B of the body, or if the metacentre M is above the point G. However, the body is unstable if metacentre point M is below the point G. Now this is in intact stability plot. So rightening movement, during the turning movement or rightening movement, GM is negative, then body is unstable. If GM is null, body is neutral, and if GM is positive, then body is stable. This is line representation. If kg defined as the weight between the keel and center of gravity, km defined as the height between the keel and metacentre, that is height of metacentre, gm defined as the height between the center of gravity and metacentre, called metacentric height, then gm could be positive. If g below the m, then ship is stable, and gm could be negative. If g above the m, then ship will be unstable. That we already seen. Then stability of floating body. The metacentre may be considered to be fixed point for a small rolling angle up to the 20 degree. In the latter case, the height weight and the buoyancy force acting on the tilted body generates an overturning movement instead of restoring movement, causing the body to collapse. So the length of metacentric height GM above G is measure of the stability. The larger it is, the more stable the floating body. So if metacentric height is less, then there will be the chances of again overturning. So to make the body more stable, the metacentric height should be a maximum, and that is the indication of stability of floating body. Reduction in the metacentric height and increasing the possibility of the accident. So ship may get turned inside in the sea, which results in an accident. So this is about metacentre and effect of metacentre and metacentric height over the turning body. Okay. In next lecture we will see some problems. Then here we end the chapter number 2 and we will start with the new chapter, chapter number 3 after that lecture. Thank you very much.